What we have seen in the before part is solving the uh, linear programming problem using simplex method. Now we are having another example. Here we have to solve this linear programming problem using simplex method. There in the previous problem we had maximize z, but here we are having minimize z. But there won't be any further changes. But there won't be any further changes. That is, the steps and all will be common only, but we have to make the slight modifications. Apart from that, all the things what we have described in the previous part is the same thing only. We are going to carry on. That is minimum z equal to 8x1 minus 2x2 subject to the constraints minus 4x1 plus 2x2 less than or equal to 1 and 5x1 minus 4x2 less than or equal to 3 and x1 comma x2 is greater than or equal to 0. So all the constraints are in the terms of less than or equal to only. So you need to express everything in terms of slab variables only. First, initially, we have to take what is our step one means. The objective function is of minimization type. We shall convert into the maximization type. So all the minimization model has to be converted into maximization. That is maximize minus at. That is minimize of minus at equal to maximize star. That is in your what is the thing in your objective function. This minimize z can be converted as maximum z star, and you have to change all the signs here. That is 8x1 means minus 8x1, minus 2x2 means plus 2x2. So everything we can convert. That is, we can convert your symbols. Then automatically the minimization has been converted into maximization type. What is our step 2 means? We need to introduce the slab variables s1 and s2, because all the inequalities are terms of the less than or equal to. So we need to introduce the slab variables. So then therefore the problem can be converted into standard form. That is, you can introduce your s1 and s2. That is minus 4x1 plus 2x2 less than plus s1 equal to 1. And the next equation is 5x1 minus 4x2 less than or equal to 3 can be written as 5x1 minus 4x2 plus s2 equal to 3. So equal to symbol if you are using means that is nothing but the standard form. That is equal to symbol if you are having means that is nothing but the standard form. That's a thing they have said to us. So how many standard variables, that is slab variables we are having here means two slab variables. Since two equations are there, we are having two slab variables. First one is S1, another one is S2. And this S1 and S2 must be introduced in the objective functions also by introducing with the coefficient 0. That is, we have to do by what means 0 S1 plus 0 S2. And here also it is nothing but S1 and S2. You have to arrange it neatly in your table. So initially, what is the next step you have to do means if you are putting x1, x2 equal to 0 in this two equation, you will be getting s1 equal to 1 and s2 equal to 2, the basic feasible solution. So this one is also okay. And then we have to start our first iteration. What is our first iteration means? The simple, that is the initial simplex method. Here, what we are having here means we will be having like this, the same Zj, that is the Cj, Cb, Yb, Xb, X1, X2, S1 and S2. And the ratio what we are calculating here. Here the Cj is nothing but what means that is what's the thing we are having in the objective function. Coefficient in the objective function minus 8 plus 2, 0, 0. So all those things we have to enter it in the top. And in the columns, what's the thing we are having here means we are having Cb, YB, XB. CB means initially all the CB values are only 0. YB means what are all the slab variables we have introduced, S1 and S2. And the corresponding variable, what the value, what we have got in the previous table, that is S1 equal to 1 and S2 equal to 3. So 1 and 3. So that we have to enter. And in the place of X1, what's the thing we are having? The first equation. What's the equation? First equation minus 4x1 plus 2x2 plus s1 equal to 1. No. So we have to try the coefficient of x1 for minus 4, x2 2, S1 means 1. Since there is no S1 in this, S2 in this first equation, you can allot that coefficient as 0 here. Similarly, the next line, that is XB means 3 for S2, already we are having. Second equation, 5 minus 4, 1 for S2. So 5 minus 4, for S1 it is 0 and S2 it is equal to 1. So you will be having like this. Next we have to calculate ZJ. ZJ means initially all the ZJ values are 0 because CB value is 0. No. So 0 into 1 plus 0 into 3, 0. 0 into minus 4 plus 0 into 5, 0. Everything will be 0. But while we are subtracting, that is Zj minus Cj, the Zj value must be subtracted. That is Zj minus Cj has to be calculated. Here in this Zj minus Cj, the most negative value is minus 2. So you have to take the corresponding column. That is x2 is the corresponding column there. And that x2 has to be divided by xb. That is 2 divided by 1 minus 4 divided by 3. But actually, we won't be taking any negative value. So only positive values are allowed there. So 2 divided by 1 is 0.5. So 0.5 means you have to match this 2. That is minus 2 and 0.5 where it is intersecting means this place is the intersection part. So you have to take the 2 as the pivot element. So already what we have seen in the previous problem, the same thing only here also we have to see that 2 has to be converted in terms of 1 and the elements below and above must be converted in terms of 0. That is our aim. So how to convert this 2 as 1 means throughout this row, we have to divide it by 2. So throughout this row, if you're dividing by 2 means you will be getting 1 by 2 minus 4 by 2, 2 by 2 as 1 and 1 and 0. So we can easily convert this 2 as 1, whatever may be that, not only for 2, but for all the other elements also we can convert in terms of what means 1. So it could be somewhat comfortable. So this 4, you have to make it as 0. How can we make it as 0? That is the next step. Throughout this, if you are converting this 1 into 1 means, throughout this row, you can multiply by 4. And then you have to subtract with this row. If you are subtracting like that means, you will be getting automatically this part as 0. So that is very much needed here. So what's the thing you have to do here means Zj minus Cj must be less than 0. The current basic solution is not optimal. That is, we should not stop our iteration here. We have to further calculate. So this is the next thing. And Zj minus 2j is equal to minus 2 is most negative and the corresponding non-basic variable x2 enters into the basis and leaving variable in the basic is s1 which corresponds to the minimum ratio of theta equal to 0.5 and there is a pivot element is 2. This thing already we have said. And in this one, this 2, if you are dividing that row throughout by 2 means you will be getting 1 and you know how to make it as 0. So this element had been converted into 0. So now you have to calculate Zj. Zj, if you are calculating means you have to multiply 0 into 1 by 2 plus 0 into 5 2 into minus 2, 0 into minus 3, everything you have to calculate. And Zj minus Cj also you have to calculate. Among all these values, we are not able to see any negative values. So we can stop our iteration here itself since all the Zj minus Cj is basic. That is, it is optimal. We are not having any negative value. So this one we can take it as the maximize z bar equal to what is a maximized z bar we are having means 1 and x1 value. What's a x1 value we are having here means there is no x1 at all. So we can consider that value as 0. Your x2 equal to 2. So x2 you can take it as what means 2, x1 equal to 0. So you can substitute these two values in your objective function. You will be getting maximize z equal to 1. Maximize z equal to 1 means minimize z equal to minus 1. You have to change the sign or else we can leave it as it is also. So this is a solution set for our given problem, given LPB problem. The next problem, what we are having here means you have to solve the linear programming problem using simplex method. The same thing only here also we are having. You are having maximize z equal to 4x1 plus 10x2 subject to the condition 2x1 plus x2. Some three conditions are given to us. All the things are in the proper way only. That is, everything is with the less than or equal to type only. And what's the first thing you have to do it here? You have to, for the objective is okay. And in the equation for all the less than or equal to, you have to introduce our slack variable. Less than means you have to add. So plus S1 plus S2 plus S3. All these S1, S2, S3 must be introduced in the objective function by giving the coefficients as 0. So 0 S1 plus 0 S2 plus 0 X3. And if you're putting X1 equal to 0, X2 equal to 0 in these equations, means you will be getting S1, S2, S3, the corresponding values there. That is 50, 100 and 90. So you'll be getting your S1, S2, S3 also. And we can frame our table like this. What is a table? Means is a J, CB, YT and XB. All the values we know how to enter. X1 means in the first equation, what are all the coefficients we'll be having in our X1, X2, X3. That is 2, 1, 1. S2 is not there. So you'll be getting 2, 1, 1. Another two format are 0, 0. Similarly, in S2, what is your second equation deals there? Means 2, 5, 1. 2, 5, 1 means S2 coefficient is 1. So what you will be having? 2, 5 in the place of S1, 1. And similarly for S3, you will be having initially ZJ means just ZJ, how can we calculate it here? Means 0 into that the corresponding column plus the next column. 0 into 50 plus 0 into 100 plus 0 into 90. What's the value will be getting 0? 0 into 2 plus 0 into 5 plus 0 into 2 is 0. So everything will be make it as 1 means 0 here. And in this one, ZJ minus CJ will be having here. And we have to multiply, that is subtract Zj minus Cj, Zj minus Cj. Among this, the most negative element is nothing but what means minus 10. So you have to take the corresponding value and you have to see divide. Most negative value means, and then you have to divide by the corresponding column. If you are dividing by 50 by 100 by 5, 90 by 3, you will be getting here that the round has been transformed to the first column, but the round is only for 5 1, not for this 2. So that we have to see it clearly. We can calculate by using the paper also. What's the thing we will be getting? And then if you're dividing, you will be getting 50, 20 and 30. Among this, which is the minimum value, you have to connect that pivot. You have to connect that column and the row. We will be getting 5 as a pivot element. Already we have said that that the pivot element has to be converted as 1 and the elements above and below must be make it as 0. That is our thing. So here this 1 should be make it as what means 0 and this 3 should be make it as what means 0. So how can we make it as 0? If you are dividing throughout this equation by 5, this element automatically will be converted in terms of 1. So if you are converting in 1, 1 minus 1 automatically will become as 0. So we can subtract the second row to first row. You will be getting automatically 0. But 3 can be make it as 0 as what means you have to multiply this new pivot row by 3 and you have to subtract next. Throughout this pivot row, you have to multiply by 3 and then you have to subtract both this. And then you automatically you will be getting this 3 also as what is 0. So this is a thing you have to do it here. So by making all these things directly, you are getting that optimal solutions and maximize that equal to 200 and x1 equal to 0 and x2 equal to 20. All these things directly we are getting. That is your x2 value is around 10. You are not having any x1 and also not x3. So your x1 value is 0 and similarly x3 value is also 0, x2 equal to 2. So these 3 values you can take it and you can go and substitute in our objective function. So what is your objective function? Maximize that equal to 4x1 plus 10x2. In this x2 value alone is possible. What is our x2 value here? What we have got it here means so that value you can fix for our x2. So therefore you will be getting 10 into 20 is nothing but 200. So therefore the maximize is at equal to 200. Therefore we can complete the solution for our given LDP. That's programming problem. Next one is overall sum for this unit is student can, that is we can understand the how to formulate and solve the simplex method problems. Keywords used here are basic variable. Basic variable means variable of your basic feasible solution, which has a non-negative value. And non-basic variable means variable of a feasible solution, which has a value equal to 0. Non-basic variables means S1 and S2. That is slag and surplus variable is nothing but a non-basic variable. Basic variable means what we are using for all the problem X1, X2, X3. That is nothing but a basic variable. Artificial variable means a non-negative variable introduced to provide basic feasible solution and initiate the simplex procedure. Slag variable, a variable corresponding to a less than or equal to type constraint. That is, where you will be using slag variable means whenever in your inequality is less than or equal to, so how to convert that inequality into equation. If one next one is surplus variable. And then basic solution. Before that, a slag variable means when we are having less than or equal to type. Surplus variable means greater than or equal to type. Whenever we are having less than or equal to, we have to add. Greater than or equal to means we have to subtract. Then we can convert that inequality into equality. So this is a basic thing we are having. And similarly for the basic solution, system of M equations, system of M equations and n variables. If your M is less than M, that is if your equation is less than the number of variables, means it's a solution where at least n minus m variables are zero. This is only the definition part. We are not using anywhere these things and all. And the basic feasible solution means system of m equations and n variables. That is, m is less than 1 is a solution where m variables are non-negative and n minus m variables are 0. This is also the basic definition. And an optimum solution means a solution where the objective function is minimized or maximized. Finally, we are getting one solution. That solution is nothing but called as what means optimum solution. And some terminal questions. Terminal questions means some other practice problems also have been given here. If you're practicing all this problem means we can identify how to use the simplex, that is how to use the graphical and simplex method neatly. That is, graphical method means if you're seeing any question with two variables, then you can definitely solve by graphical method. In case if they are specifying by using the simplex only, you have to solve means we have to solve that system of equations by simplex method alone. So what are all the things we are seen so far here means initially we have seen the introduction part. Introduction part, it is nothing but what means linear programming problem formulation already we have seen in the unit 2 itself. And in this, the objective for that unit is nothing but we have to solve the linear programming by using the graphical and simplex method. And the introduction part, what they have said means if you are having only two variables, it can be solved easily by simplex. That is graphical. More than two variables means you have to solve it by using the simplex method. And the working procedure for graphical method have been described here. That is, you have to find out the coordinates. Neatly, you have to find out the coordinate. And for each equations, if you are having two set of coordinates, means you have to connect that coordinates and you have to draw the line, and above the line, you have to mark that equation also. What is that equation? And then you have to find out your, if it is less than or equal to type means you have to shade inside the region, greater than or equal to type means you have to shade outside the region, and you have to find which part is common for all, for less than or equal to and also for greater than or equal to. That part is nothing but the feasible region. That part can be said as what means feasible region. And graphical method have been described here neatly. All we have explained. And next to this graphical method, what's the thing we are having here means we are having the simplex method. Simplex method means you should know how to frame the table. Here only we'll be introducing the slag and surplus variable. Slag means less than or equal to type. Surplus means greater than or equal to type. If your introducing slack and surplus variable and entering all the values in the table, you will be getting the value for Zj, and then you will be getting the value for Zj minus Cj, and we can get the and we can finally get the value for our objective function. That is nothing but the optimal solution for the given problem. And the problems here also we have seen, and with the help of all these things, if we are solving the problem given in the terminal questions, that is the problem given for practice, means we can directly understand the method of simplex and graphical properly. Thank you.